Lesson 2, topic, midpoint and bisectors. Learning target. I can find the midpoint of a segment and use the bisector to solve problems. First off, your vocabulary. Congruent segments. Line segments that have the same length. So ways to know that. Sometimes they'll use little tick marks to mark that the segments have the same length. Now, notice this is segments. It cannot be lines, only segments. So we'll use these little tick marks. Sometimes they'll have 2 tick marks, drawing a segment. And it could be 2 tick marks like that, but anything that matches with the tick marks would be congruent. So this would not be congruent to this because they don't have the same number of tick marks. Lengths that are equal. So if we said that the length of segment AB was equal to CB, we'd know that those 2 segments were then congruent. Congruent, if you can see the symbol, is just an equal sign with a little squiggly on top. That is our symbol for congruent. Midpoint, point on a line segment that divides the segment into 2 congruent segments. That's why we talked about congruent segments first. So the midpoint is smack dab in the middle of a segment, which means it cuts it in half and makes the 2 parts equal. So if we knew that AM was 7, we would know that MB was also 7. Segment bisector. A point, ray, line, or line segment or plane that intersects the segment at the midpoint. So it's anything that cuts through a segment at its midpoint. So if M was the midpoint there, which we know it is because it's cutting it into 2 congruent pieces, we call that a segment bisector. So it's something that goes through the midpoint, and it can be a point, ray, line segment, or plane. Let's practice. We know that point S is the midpoint of RT. Find the length of RS, then find the length of RT. So we know that the midpoint S is cutting these segments in half, so we know that RS, that piece right there, is equal to ST. We know that because S is that midpoint, so these 2 pieces are congruent, which means their measures are equal, which means we can replace RS with its measure, which is 5x minus 2. So I'm going to erase that and replace it with 5x minus 2. And then we can also replace ST with its measure, which is 3x plus 8. Solve that equation. Going back to our linear algebra skills, undo the 3x with minus 3x on both sides to get our variable to one side. 5x minus 3x is 2x. 3x minus 3x is nothing. We want to get this minus 2 over here to join that 8, so we'd undo minus 2 with plus 2. 8 plus 2 is 10. 2x equals 10. Divide by 2 on both sides. X equals 5. But we have to be careful because we're not done. We have to ask ourselves, what did we want to find? We wanted to find the length of RS. So that measurement. So RS is this piece right here, which is equal to 5x minus 2. So that means we can put x in and solve, or evaluate, Replace x with 5, and we get 5 times 5 is 25, minus 2 is 23. So we know RS is 23. And then find the length of RT. So the length of RT would be the whole piece. Well, we know that RS is 23, which makes ST 23. So the whole thing would be 23 plus 23, which is 46. Extension. Now, if we're working on a coordinate plane, there is a midpoint formula to find the midpoint of any segment on the coordinate plane. So if A is x1, y1, so any coordinate point, and B is x2, y2, you should remember that phrasing from the distance formula from slope last year. We worked with that coordinate point formula. Our point's in a coordinate plane. then the midpoint M of segment AB has the coordinates of this. So the sum of your two x variables divided by 2. Remember, the midpoint cuts in half, so it makes sense that we would divide by 2. And then the sum of your y values divided by 2. So we're really just finding the average of the 2 points. So the endpoints of segment RS are, R is 1, -3. So let's find that. 1, -3 right there. And I'm going to label it R. And then we have S is 4, 2. So we can find 4, 2 right here. And I'll label it S. Find the coordinates of midpoint M. So here's our line, and we want to find the point that would be exactly in the middle. Now we can kind of get an estimate of where that might be by looking at our graph, but we don't know exactly where it would be. We can't just like pick a point and pretend. So we're going to use our formula. So we have coordinate points 1, -3 for R, and 4, 2. So the first step would be labeling those points. We have x1, y1, x2, y2. And now we want to plug those into our formula right up here. So this formula that we're going to be using is the sum of our x values. So x1 is 1. So I'm going to replace this x1 with a 1, plus x2 is 4. So I'm going to replace this x2 with a 4. And then for our y's, we have y1 is -3. So I'm going to replace this y1 with -3. And then our y2 with 2. And now we can just evaluate each piece. So our first piece, we have 1 plus 4 divided by 2. Well, 1 plus 4 is 5. 5 divided by 2 would be 2.5. And yes, you will get decimals sometimes because division does not always work out evenly. And then on this side, we have -3 plus 2. -3 plus 2 is -1 over 2. -1 divided by 2 equals -0.5. So our midpoint M would be 2.5, -0.5. So if we find that on the graph, 2.5, -1.5 be right about there, which if we look, does look just about right in the middle of that line. So we always want to graph it to make sure that we don't always go off of looks, but in this case, we can use it as like a checking point. Are we pretty close, or does it look very off where we should double check our mathematics? That is all the notes for lesson 2. Go ahead and go on into the practice.